Hello, my warriors. Good morning. Hi, Ankit. Hello, Samuel. Welcome aboard. Can you guys see me? Can you guys hear me loud and clear? Let me know. This is Shreyas here, your physics master teacher for this channel, going live. So, how are you guys? Are you guys excited? Because yesterday the news was broken that the CBSE 12th standard examination has been cancelled. So finally, now I think your only attention, your only focus should be JEE Mains. What do you guys say? Okay, yes, Edas Gupta is good, Ankit. It is very good. Yep. And a lot of you were in fact waiting for that news to be broken out by our education minister. And yesterday, finally it has been made official. So, there are multiple options out there also. In fact, they are also proposing that you will be able to write the CBSE board examination later on at some other point of time, like they are giving the 10th standard students some options. So that is also there, because you might need the 12th standard marks at some point of time for some other job, or for some interview, or for some college application and stuff like that. And yeah, hello Bhavya, welcome aboard. This also means that most probably the JEE Mains announcement is very imminent. It's very likely it's going to happen very soon, and probably you might get the dates, because the second wave is almost withering away, and we are all expecting that the situation will normalize in the coming few weeks, and hopefully the announcement will happen very soon. And I know once the date is announced, you guys will all get anxious and nervous, and you will hardly have any time for the last leg. So guys, get ready. Yeah, and this is the Zero to Hero series, and I'm Shreyas, and you can know more about me on my Instagram handle, that's Shreyas_Vedantu. And before we begin our class, do not forget to hit the like button out there. Smash the like button so that you show our channel your support, your love. And one more thing I request you to do, please hit the subscribe button so that you do not miss any of our lectures. By the way, this is the schedule for this week. You can just have a look at it. Yep. And like you can see, today we are going to do optical instruments in the Zero to Hero series. Tonight we are going to have a 11th standard class on dot and vector product. Tomorrow, advanced question on current electricity, and then day after tomorrow, advanced questions on vectors and a Menti quiz, and a special session for you guys on Saturday. Well, this is a tentative timetable. It might change a little bit up and down, but for now, this is the schedule for this week. So guys, if you are wanting to start your preparation, if you want to improve your score, if you feel now that the board examination is cancelled, now that most likely even the state board examinations might get postponed or get cancelled because of the pandemic like situation, so I think now is the right time to give your final boost. Like if you have played games, you see there is something like a booster shot. Even in vaccine there is something like a booster shot, isn't it? So if you want that final push, so that you have put in your 100%, there is no stone unturned, and you can see our results from Vedantu. These are the Vedantu toppers who have got 99.96 percentile, 99.97, 99.91 percentile, and there are many more people. In fact, there are many students who have got 100 percentile in the individual subjects of physics, chemistry and maths, and 1 in 2 Vedantu student is already qualified for JEE Advanced. In fact, if you see our rates at which the students qualify the JEE Advanced examination, it's almost 6 to 7 times higher than the other institutes or the national average. Now the CBSE board is not there, but just giving you a fact, you can see even the performance in CBSE was 5 to 6 times higher. Now all this is possible because of our continuous efforts, the dedicated master teachers, the assignments, the mock tests, the doubt solving that we give you inside the class. So I feel you need that final push, so that guys, this is your last month. This is what I feel before the announcement happens. So do not delay your decision to get yourself enrolled into a crash course which Vedantu is starting for you. So again, the next date is on the coming Monday, and this crash course will cover the entire 11th and 12th standard syllabus. I personally feel you should get yourself enrolled and push yourself for the final leg. And remember, the crash course price is not 10,000, it's 6,000 when you use the coupon code SHCC. And when you use the coupon code, my coupon code, then what happens is that if any problem happens, then you can definitely get in touch and I can help you resolve those issues. So do that. You'll also get the discount. The link for joining the crash course is there in the description box below. Now let's talk about the first basic thing, and that is the simple microscope. This is the first thing that I want you to understand. See guys, whenever you see an object, okay, whenever you see an object, then the size, the clarity, the crispiness of that object depends on how far it is. Obviously, if I'm seeing this pen, it is really far away, it won't be so clear. So to see it clearly, I'll bring it close. But I cannot bring it very close because there is a limit, and the distance till which I can bring that pen close, till which I can see the pen or any object very clearly, is called as least distance of distinct vision. So whenever objects are far away, they subtend a very small angle. When this object comes close, they subtend a larger angle. So larger the angle, better it is for me to see that object very clearly and not see a blurred image as such. So I can see it magnified. But if I bring it very close, then I cannot see it because my eyes are unable to focus that object onto the retina of my eye. So remember this distance, capital D, which is on an average 25 centimeters for an average human being, okay, and that's called as the least distance of distinct vision. And the magnification or the clarity of an object depends on the angle which the object subtends. Okay, hello Jay, hello Vish, hello Ankit, hello everyone, hi Abhi. Yeah, no problem Vish. Okay, so keep all these pointers in mind. By the way, the entire PDF will be available to you in the Telegram channel. So in case you have not joined the Telegram channel, join it. I will give you all the notes, all the important formulas, the diagrams along with the questions in our Telegram channel. So go ahead, join the group in case you have not joined it yet. And if you have forgotten to like the video, please do that right away. Okay, so now the next point is, what if I want to see this object at a much larger angle? So I take help of an optical instrument. The job of an optical instrument is nothing but to enlarge the angle so that I can see the object very clearly. So like you can see, this is a magnifying glass, nothing but a convex lens, nothing else. Yep, this is nothing but a convex lens. Look at this, the object is placed somewhere over here. The rays will refract through the lens. You can see that the rays will refract through the lens. One of the ray is going parallel, and the ray which goes parallel will go through the focus. The ray which goes through the optical center will go, or the pole will continue its path undeviated. So you can see it forms an erect, magnified and virtual image. I'm pretty sure everybody has used a magnifying glass at some point of time in your life. So this object's image is formed here, and it is erect, it is magnified, and it is virtual because it is on this side. So now you can see the angle is much larger. So now you can view that image at a much larger angle and it appears to be more clear. I hope this is clear. Yep, everybody understood this? Now, this is the job of not just magnifying glass, but in fact any instrument, optical instrument that you take help of. The job of any optical instrument is to make sure that the image of the object subtends a larger angle, and if this image is brought, okay, if this image is brought close to the eye, and remember there is a limit to that, that is D, which is 25 centimeters. So you cannot bring it closer than 25 centimeters because then you won't be able to even see the image. Then the object will be the most clearest and the most magnified. I hope this makes sense. I'll repeat, this object's image, when is at a distance of D from your eyepiece or from where you are seeing it, that's when you are going to see the object's image very clear, very magnified, and it will subtend a very large angle. That's what it is. Okay, now let's see some basic formulas. Yeah, let's see some basic formulas which are needed. The first formula that you are going to need is magnifying power. Now please understand, this is different from your usual power that you have studied in optics. It's not image height upon object height. Nah, this is quite different. Read this formula, and this is not in diopters. It's unitless. This is magnifying power of an optical instrument, and in the numerator you have the angle which the object makes with the instrument, the angle which the object makes by using that instrument. So when you use the instrument, what angle does it make? And in the denominator you have the angle which the object makes without that instrument at least distance of distinct vision. So for example, okay, by using, let's say, a magnifying glass, okay, by using a magnifying glass, let's say that object subtends 60 degrees. The object subtends 60 degrees, okay, using that magnifying glass. Without that magnifying glass, let's say that object subtends 30 degrees. 60 by 30, that's 2. So the magnifying power of that instrument is 2. The magnifying power is 2. That's what it means. Okay. So that's how this works. Okay. Now, keeping this in mind, let's get going ahead to the next part. Now, when that image is formed by the lens, okay, when you place that magnifying glass, you have that object, the image can be formed at different places. It can be formed at infinity, and it can be formed at D, which is the least distance of distinct vision. There are two situations for which you should remember the formula. When it is formed at infinity, this value, the magnifying power, is D by F. What is D? 25 centimeters, least distance of distinct vision. And F is the focal length of the lens. Keep this in mind. Next, when the image is formed at D, that means the image is very close to the magnifying glass. You cannot get it closer because then you won't be able to see it properly. Then the formula for magnification is 1 plus D by F. So very simple, this number will come, this ratio will come again and again. D by F, very less magnification when you are at infinity, when the image is at infinity. When it comes close and it comes at least distance of distinct vision, it becomes more. By how much? 1. So 1 plus D by F. Remember these formulas. Okay, very important formulas that you should keep in mind. Let's see whether you can start solving these questions coming up on your screen right away. A person using a lens as a simple microscope sees which of the following? Come on guys, let me know. Is it upright virtual? Is it inverted real? Or is it inverted virtual or upright real magnified? Come on guys, Ankit says B. Read the options very carefully. A person using a lens as a simple microscope or a magnifying glass. Simple microscope is nothing but a magnifying glass. I just showed you the ray diagram of a simple microscope. It looks something like this. Look at that. This is the object, this is the image. Look at the pencil is here and it is still like this. That means it is upright. Yep, it is upright, it is erect, it is not inverted. Next, it is magnified, you can see, obviously it's magnified, and it is a virtual image. So hence, it's an upright, virtual and magnified image. Magnified word was not there, but if it was there, then you will obviously mark that as well. So that's the answer guys. I hope this is very clear. Yeah, remember that ray diagram, that's very important. No, I have not forgotten you guys. In fact, you guys have even a better opportunity to revise even the 11th standard portions through the Pathfinder as well as the Nurture series. Plus, I did so many mock tests. We did so many mock tests for VIT EEE. So I understand this week I'm also held up with other work. That's why I kept one session, but otherwise I will keep 2 sessions. Don't worry. Okay. So yeah, I will not forget any 2021, 2022 or 2023 aspirants. I love you all and I'm always there for you. Okay. Chalo. Hello Minecraft. Let's see whether you can do this question. Okay. Now I'll show you how the diagram looks like. See, this is a microscope. When the glass is not there, this microscope is focused at a point. The moment you put this glass slab, you'll have to move the microscope to show or to focus on that mark again. So guys, the whole idea over here is that virtual means that the rays appear to come from some point. You can see the image without a screen. Like when you hold a magnifying glass, alright, you see the magnified object behind the lens. You see it behind. You don't need a screen for that. You can see as if it is there. So it feels as if the rays are coming from somewhere else. That's the meaning of that virtual image. Okay. Now, the moment you put a glass slab, what will happen? The object over here, the mark which is there, it is going to shift. It's going to shift, right? So you just need to find out the shift, and there is a beautiful formula for shift due to a slab. So shift due to a slab is given by, what's the formula? It's thickness of the slab into 1 minus 1 by mu. That's the formula. Now just substitute everything. The thickness of the slab is 3 centimeters. The refractive index is 1.5. Now 1.5 means it is 3 by 2. Okay. Now that goes on the top. So it will become 2 by 3. 1 minus 2 by 3 is nothing but 1 by 3. Now 1 by 3 into 3, that's going to be nothing but 1 centimeter. So what you need to do is, because you put the glass slab, that mark is going to shift up by 1 centimeter. So to focus it again, you just take this microscope and move it up by exactly 1 centimeter. So again, it's back onto track and it's focused. So hence the answer is 1 centimeter upwards. Yep, that's how it is. Beautiful. Great. Let's get going to the next question coming up on your screen. Very important questions these are. So let's see the next question. You take a glass, magnifying glass, and read the newspaper. When you move the magnifying glass away from the newspaper, then what will happen? Is the text going to become blurred? Is the text going to be more focused? Is it the magnification is going to be reduced, or is the magnification going to increase? What do you think will happen? I'll give you a hint. Try to roughly draw or recollect the ray diagrams for convex lens for different positions. Object at infinity, object at 2f, object at f. If you remember those diagrams, I'm pretty sure you will get this problem. Come on, my warriors, think about it. No problem, Minecraft. Yes, you will answer all the questions, and even if you don't answer, it's okay. Just learn from these questions. That's very important. Abhinay says B, Shreyas Kapri says D, V. Kopina says D. Come on, guys, figure this out. What do you think is the answer? Yep. Well. I'll show you the ray diagrams in case you have forgotten it. This is how the ray diagrams look like. See, when it is focused, when you're holding that magnifying glass, then it is focused, you are able to read it very clearly. But when you move it away, the object from the lens will move away, the distance of object will increase. So see, look at these ray diagrams of convex lens. This is when the object is at focus, image is at infinity. The object goes slightly away from the lens. You can see over here. Okay, the object goes slightly away from the lens. Okay, and you can see the image is on that side, and it's not at infinity, but it's very far away. Then when the object distance further increases, you can see the image size becomes smaller, and when the object moves even further away, the image becomes even smaller. You can see when the object and lens distance increases, the image which is there on the other side has become smaller and smaller. So it should become diminished, and obviously the text will become blurred, because earlier it was properly focused. Now, because you have changed the distance, the image won't be formed at the same place, and hence it will not be focused. You would have seen that. I mean, this is by common sense that you know it is going to become blurred, because the moment object distance changes, the image will be formed at a different place. It will no longer be formed at your eye, okay, and it will be formed somewhere else, because of which it will appear blurred. Yep, yes. So Ayush, yes, I have covered prism in just optics. I have just conducted a lecture on optics. In that I have covered prism, so you can watch that. Okay, now this is the next important part. Okay, this is the next important part. This is called as the compound microscope. Now, a simple microscope has how many lenses? One lens. A compound microscope will have two convex lenses. And let's have a look at the ray diagram and some basic construction. The first thing that you should know is that this is the eyepiece. This is where you see it from. This is the objective. This is where you put your amoeba, blood cell or hair or some tissue which has to be magnified using this microscope. Okay, that's what has to be done. This is the eyepiece. This is the eyepiece. This is the objective. Objective is where you place the object. Eyepiece is where you see it. Now the most important thing is the focal length of the eye lens is much more or higher than the focal length of the objective. So this guy, the objective, has a very small focal length. That means it is very powerful. This lens is more powerful than this lens. That's why this has a less focal length. This has bigger focal length. Remember, power and focal length are inversely related. Next important thing, this diameter at the eye lens, you can see this is bigger, this is smaller. So the the diameter of the objective is small, the diameter of the eyepiece is big. That's the next important thing that you should know. Next important thing, resolving power. You might get direct questions. If you get a direct question, you will thank me later and you'll be like, yes sir, gave us the formula, oh just have to substitute. Believe me, it's that simple. Just remember this formula and I'll tell you what it means. Resolving power is nothing but, is the reciprocal of that distance between two objects which can just be resolved using a microscope. Just imagine there are two legs of some microorganism. They are very close by, okay? They are very close by. Now, when you see it through a microscope, maybe they don't appear different. Maybe you are not able to distinguish between them. So, two objects which are very close by, if you are not able to distinguish, then it is said to be unresolved. But if two objects which are close by and you are able to see them distinctly, clearly, separately, then it is said to be resolved. I hope the meaning of the word resolved is clear. So resolving power means is the reciprocal of the distance. Now what does it mean? Reciprocal of the distance. This distance, if this distance is small, okay? If this distance is small, that means two objects which are very close to each other can also be split, can also be seen separately using the microscope. That means it has a very good resolving power. That's why it's the reciprocal. If this distance is large, that means the two objects have to be very far, only then I can see them clearly and distinctly. So that power is not so good, it's a bad resolving power. Now the formula for that is 2 mu sine theta by lambda. Lambda is the light's wavelength, the wavelength of the light which enters in the microscope. Mu is the refractive index of the medium. Now the medium which fills around it, the medium which is around it, that's the refractive index of that. And this theta, very important, it is called as the semi-cone angle. It's the semi-cone angle. That means from those objects, the rays of the light will be coming in like this, okay, and it will be entering inside the lens. So the semi-cone angle means, you can see there is a cone formed over here. If I draw a line like this and a line like this, this angle is called as theta. Okay, so this is called as theta. Remember that. Yep. Week opener JEE will happen. It has to happen. There is no chance that JEE will get cancelled. JEE will happen. Mark my words. Okay, it's impossible for JEE to be cancelled. Okay, so very important slide. I hope you have made a note of this. I'll go to the next slide and show you some more ray diagrams. Very important, guys. Remember one thing. Once you study this topic under me and you remember these formulas, nobody will stop you from getting those 4 marks in the JEE Mains examination. Now every mark counts, because let me tell you, everybody is going to prepare all these topics. So if you are the person who is going to leave a particular topic, then you will be at a disadvantage, because everybody has got a lot of time and they are all pushing themselves for that extra edge. So you cannot leave any topic. Understand that. Otherwise, I'll come with bitsat strategy later on. Don't worry. Okay. Now, first thing, this is where the object is kept. This is the objective lens. You can see it's smaller. Okay. This is where you're going to see from. This is the eyepiece lens. It's a bigger one. You can see that again. Now, see what has been done. The object is placed at a distance of UO. What does this O stands for? Objective. This O stands for objective, guys. Okay. And you can see this object is slightly away from the focal length. Okay. If this is the focal length, it's slightly away. So when you have a convex lens and an object which is slightly beyond the focal point, the image is going to be inverted. It is going to be inverted and it's going to be real. You can see it's on the other side. it's going to be inverted, and it's going to be real. Now this image is going to act like an object for this lens. So that's why you will see this image has been shown as the at a particular distance of object distance UE. So this image is at a distance of U. U stands for object distance, E stands for eyepiece. And that guy's image is formed over here. You can see it is formed over here. Be careful, since the image is virtual, that means this image should be placed such that when it becomes the object for the eyepiece, it's before the focus. Recollect convex lenses ray diagrams. When, if you have forgotten, I can show that to you. This one over here. When the object is before the focus, only then the image is virtual. When the object is beyond the focus, then it is real and inverted. So guys, that's why I'm saying this object should be before the focus of this lens. Only then the image is magnified and it is virtual. That's what it is. Yep. I hope this is clear. I hope this is clear. Yep. Now, the formulas that you should know. Number one is the length of the tube. Length of the tube. Look at this. Length of the tube means the distance from the objective lens to the eyepiece lens. Again, I'll repeat. The length of the tube, whenever they ask you what they are asking, what's the distance between the objective and the eyepiece lens. You can clearly see, since this lens forms an image here and this image is the object for this lens, so the object distance for the eyepiece plus the image distance for the objective, the image distance for the objective plus the object distance for the eyepiece totally should give you the length of the tube. Should give you the length of the tube. That's how it is. Okay, great. That's number one. Number two, the image when it is formed at D, there is a formula. Okay, the image when it is formed at D, there is a formula. Now you should know that. See guys, remember I had just told you, forget this. This formula for a simple microscope, do you remember this? 1 plus D by F. This was the formula which I just showed you for a simple microscope. The only additional term that is there, so this is for simple microscope. The only additional term which is there is V naught by U naught. V naught for the objective by U naught for the objective. That's the only term which is going to be there. Now please remember one thing, because the image is formed at D, the image is formed at D, that means the final image distance VE is D. You can see that VE is nothing but D. The image is finally formed at the least distance of distinct vision. And when that happens, it occurs in such a way that this image which is forms very close. It forms very close to the lens. So that's why because it forms very close to the lens, this value approximately becomes 0. That's why this value approximately becomes 0, very small, and this object, this image distance will approximately become the length of the tube. That's why you can see this, for the objective, the image distance is approximately equal to the length of the tube. This is something which you should know. And the object as such, this object is placed very close to the focus. That's why you can see this number over here. Okay, so these are the parameters which are very important. I'll repeat. This is 1 plus D by F, which is the standard simple microscope formula. V by U is your magnification formula. Just multiply these two numbers, you will get this. Okay, and what happens, the final image is formed at D. The image which is intermediate is formed very close to the eyepiece. Remember that the image is formed very close to the eyepiece, so UE is 0 and the length of the tube and the image of the objective is almost the same. That's why you're seeing that over here. That's number one. Number two, the second scenario which you are supposed to remember is this one. If the image is formed at infinity, then instead of 1 plus d by f, it is just d by f. That's it. It's just d by f. The rest of the terms remain the same. And the only thing you should know is the final image distance is at infinity. Yes, the final image distance is at infinity. When can the image be formed at infinity? Only when this intermediate image, okay, so if this final image is at infinity, that means this intermediate image should be at the focus of the eyepiece. So when this is at the focus, you will see the image will be formed at infinity. So remember these formulas. Please take a screenshot. Don't worry, these formulas look very confusing, but when you start solving problems, you will realize it's not that difficult when you apply it. Okay, let's do this. The magnifying power of a compound microscope increases with, okay, generally you use the microscope at least distance of distinct vision. Generally you do not use it for infinity, guys. Let me also tell you that. Okay, come on guys, think about it. I'll just give you the formula in case you have forgotten. The magnification formula was minus V naught by U naught 1 plus D by FE. Come on guys, I've just told you this. I've just told you about this. Usually you use the microscope at least distance of distinct vision. Obviously you do not want the amoeba's image to be formed at infinity. Obviously you want the amoeba's image or the microorganism or whatever small thing you are looking, the image should be formed very close to the eye. All right, and especially at least distance of distinct vision. So what is the object distance? This object distance is approximately FO. In case you have forgotten, I'm just reminding you. So you have these two lenses. The object is placed almost at focal length of the objective length, objective lens. So that means, don't you see, M is inversely proportional to F naught and is also inversely proportional to Fe. Bigger Fe, bigger FO, lesser the power. Small FO, small Fe, bigger magnifying power. So hence the answer should be option number D. Focal lengths of both eyepiece and the objective should be decreased. Smaller the values, bigger the magnifying power, like you just saw in the formula. Correcto. It's option D. Yes, Professor Remy. Yes, Yalini. Yes, Shreyas Kapri. Hardik, I guess you got it now. Okay, let's do this question. Trust me, this is like, you know, you will feel that it is difficult initially, but once you look at how to solve it, you will realize it's nothing other than convex lenses. Look at the question, let's read it. In a compound microscope, the focal length of the objective is 1.2. Let's write down what and all we know. Let's write down. So focal length of the objective is 1.2 centimeters. The focal length of the eyepiece, FE, is how much? It is 3 centimeters. When the object is kept at a distance of 1.25 centimeters in front of the objective, that means UO, the object distance for the objective, is 1.25 centimeters, but it will be negative because it will be on the left side of the lens. That's why it's minus. The final image is formed at infinity. That means VE, the image distance for the eyepiece, is infinity. Okay, what is the magnifying power of the compound microscope? So come on guys, let's see what do we do. What is the magnifying power of the compound microscope? So first thing that we need to do is think about the formula. Where is it? Yep. See. Okay. Magnifying powers formula. Let's see. What was that? Magnifying powers formula when it is at infinity. Try and recollect what was the formula. It was V naught by U naught into D by F. Remember, there is no 1 plus. There is no 1 plus. 1 plus is there only when you see it very close at distinct vision. At infinity, it is just D by F. Keep this in mind. Yes, correct, Ankit. It always seems impossible until it is done. Aditya, welcome aboard. Okay. Now let's see what and all we know. D value, yes, I know. FE value, I know. VO, nah. UO, yes, I know UO. So the only thing which I do not know, is VO. The only thing I do not know is VO. How do I get that? I think I know what to do. See guys, the only thing what I need to do is, this is the objective lens. The object, okay, the object is at 1.25 centimeters. Where will the image be formed? Where will the image be formed? I think I can do this. Look, use the lens maker formula. 1 by VO minus 1 by UO is equal to 1 by FO. Lens maker formula, nothing else. So 1 by VO, I do not know the value of VO, minus 1 by UO. What is the value of UO? It is negative 1.25. Negative 1.25 is equal to 1 by FO. What is FO? It is 1.2 guys. It's 1.2. Therefore, 1 by VO will be equal to 1 by 1.2 minus is plus. Take it on the other side. It will again become minus 1 by 1.25. Now do the math. Just do the math and quickly tell me, Holy Bible, the Pathfinder is not running slow. In fact, it's running at a perfect space. Okay, don't blame it. It's running at a perfect space. Yeah. In fact, at this point of time, a 12th standard student would have completed, current electricity. We have completed 3 chapters. What more do you want me to do? Okay, and I have told you that I am going to complete the syllabus nice and cozily by around October. So have faith, and it is not running slow. In fact, I want you to practice a lot of problems, the Holy Bible. Okay, understand that. Okay, come on, let's see. Let's see. What is the final answer for VO? What is the value of VO that you are getting? What is the value of VO that you just got? Come on, quickly tell me. Yep, are you getting 30 centimeters? Excellent. Excellent. Yes, VO will be 30 centimeters. Now it's just a matter of substitution. Just substitute in the formula. This is 30. UO is nothing but 1.25. We are just worried about the magnitude, by the way, into D, which is 25, and FE is nothing but 3. So if you want, you can write this as 3 and this will become 10. Okay, and that's going to become 250. 250 by 1.25, guys, how much is going to be? 250 and 125. It goes 2 times, but there is 1.25 below, so 200 times. So that's the answer, option A. So it looks difficult at the start, but it is not. It looks difficult. Understand that. Okay, let's get moving. Yeah, Ritu, this is for 11th moving 12th also, but you should have studied optics. Please understand, this is not from the basics. This is not the long-term batch lecture. This is specially meant for those students who have already revised or already have some idea about microscopes and telescopes. If you have not studied it at all, you are seeing it for the first time, then I would advise you to wait and wait for me to start it in the Pathfinder series. Okay, let's get going to the next one. In a compound microscope, the focal lengths of 2 lenses are this much and this much centimeter. Object is at this much centimeter from the objective. Final image is at least distance, that is 25 centimeters. What is the distance between the 2 lenses? Let's do this question. Again, it looks very crazy, but trust me, it is not. First of all, let's write down the formula that we need for the length of the tube. For the length of the tube, try and recollect. It's how far the image is formed from the objective, that means VO, plus how far is the intermediate image from the eyepiece, which acts like the object distance. So it is UE. This is what it is. Now what and all do I know? Let's see. Focal lengths of the lenses are given. Okay, so 1.5, that's going to be the objective, and that's going to be 1.5 centimeters. Then focal length of the eyepiece, that's given to be 6.25 centimeters. Then the object is placed at 2 centimeters from the objective. That means UO, object distance of the objective, is minus how much? 2 centimeters. And the final image, that means VE, is at negative 25 centimeters. This is what is given to me. Guys, Think about it now, what we need to do. We need to know VO, we need to find out VO, and we need to find UE. It's very obvious what to do now. Because I know UO, I can find out VO by lens formula. And because I know V, I can find UE using lens formula. Don't you see, it's just application of lens formula. That's it, 2 times. So guys, let's apply it. Let's apply it for the objective. Okay, for the objective. Think about it. If I use the lens maker formula, 1 by VO minus 1 by UO is equal to 1 by FO. So what is VO? Check this out. Oh, I do not know that. I need to figure that out. Minus 1 by UO. UO is minus 2. Okay, it was given. The object is at 2 centimeters from the objective. Correct? Next is equal to 1 by FO. What is the focal length? It is 1.5 centimeters. So guys, quickly tell me, when I move this around, minus minus is plus, take it to the other side, it will become minus sign again. So it will be 1 by 1.5 minus 1 by 2. So what is the value of VO that you are getting? Quickly guys, come on my warriors. Yes, Yalini, correct, lens formula. Quickly tell me what's the answer. Waiting for you guys, you need to work it out. So for the eyepiece is what I'm going to do next. Come on. Come on, for the eyepiece. Yes, yes, yes. Come on, come on, come on. What is the VO value? Yes, Rimi, correcto. It is 6 centimeters. Excelente. It is 6 centimeters. Beautiful. Lens maker formula. Just do the math. Come on, take the LCM. Now, for the eyepiece, do the same thing. 1 by VE minus 1 by UE is equal to 1 by FE. Just substitute everything, guys. VE value, I know it is minus 25 centimeters. Minus 25. Minus 1 by UE, I do not know the value of UE, is equal to 1 by FE. FE is 6.25 centimeters. So I need this value, right? I need this value. So therefore, 1 by UE, take this on the other side, 6.25 comes here, will be 1 by negative 25 minus 1 by 6.25. So just do the math, you will get the answer. UE will be equal to, come on, minus 25 multiplied by 6.25 divided by 25 plus 6.25. Now 25 plus 6.25 is nothing but going to be 31.25. Yep, it's going to be 31.25. So you can do that, guys, 31.25. Yep. And now it's just a matter of the simple calculations that you need to do out here. 25 and 3125, how many times does it go? Yes, how many times does it go? Does it go 125 times? Just check this out. Does it go 125 times? This will go, yep, actually 1.25 times. And this 1.25 will go with 6.25. How many times? How many times does it go? Does it go 5 times? Just check this out. It will go 5 times. Yep. And that means the final answer will be, yeah, it will be minus 5 centimeters. But please understand, these are magnitudes. These, you should not put actual signs, then you will get the wrong answer. So the magnitude wise, this is 5, and VO, how much did we get? We got it as 6 centimeters. So 6 plus 5, which is 11 centimeter. That's the final answer, guys. That's the final answer. Rini, I think you made a calculation mistake. Just check it out. The UE should come out to be negative 5 centimeters. No, it is not 1.7. Just check that out. Be careful. I think you made a silly mistake somewhere. Yeah. So this is how you need to do it. It's nothing but lens formula. So this can come like a numerical type of question as well in JEE Mains, where you might have to mark the answers in integers. Let's do one last question on microscope. Yeah, 11 centimeters is the answer. Let's do one last question and then we'll go to telescope, few formulas, and that's it. Okay. Find the resolving power. Let's see how many of you can do this. The angle is given, wavelength is given, refractive index is given. I just gave you a formula. Just some time back. If you remember that formula for resolving power, you will get it. Have you forgotten it? Well, resolving power. What is the formula for resolving power? I just gave you some time back. What was it? 2 mu sine theta. Remember that? 2 mu sine theta divided by what? Wavelength. Yes, divided by wavelength. That's how it is. Now just substitute. Refractive index 1. Now a lot of people, yes, lambda, what is the value of lambda? Lambda is 600 nanometer. So that means into 10 to the power minus 9. Sin theta. Now a lot of people are going to put 60 degrees. Now that's going to be wrong, guys. You have to put it as 30 degrees. Now I'll tell you why. They have clearly mentioned that the cone angle is 60 degree. That means if this is the cone, this entire angle is 60 degree. But do not forget one thing. This theta, I have told you, is the semi-cone angle. I've been clearly telling you this. So semi-cone angle, that means exactly half of that, which is 30 degrees. So if you substitute a wrong thing, then probably you're going to get a wrong answer. So sine 30, guys. Yeah. Now you can solve this. Okay, sine 30. So 2 into sine 30, that's 1. Okay, and 6 into 10 to the power. Look at that. 2 zeros goes. Okay, so it's going to be 10 to the power minus 7. Now 1 by 6 into 10 to the power minus 7, that's going to be 0.167 into 10 to the power 7. But you can write it as this, I guess. 1.67 into 10 to the power 6. That's the answer. Yeah. Is that clear? So these are the tricks. These are the small catches which are there in JEE Mains. Now you might know the formula, but you might read this 60 degrees as theta, but that is wrong. So now you will never make a mistake. I'm guaranteeing you, I'm for sure that, you know, if these kind of questions come in your JEE Mains examination, and if you have solved it by hand, trust me, you are going to get those 4 marks. And all the other people who do not know these formulas or who do not know the small things, they will lose those marks or get negative marks. So plus 4 guaranteed if you compare it with the other students. That's how it is. Okay. Now, by the way, for all the students who want to join the crash course, before going to Telescope, let me just give you this small piece of information. Our crash course platform looks like this, where there is a teacher. You can chat with a special teacher apart from the main teacher. The main teacher is the master teacher. There is a separate teacher called as a class teacher with whom you can chat and ask any doubts even during a class. So the chats are regulated. You cannot see others' doubts, but if somebody's doubt is very nice, then the teacher may discuss those doubts in the class. And you have quizzes and leaderboards in every class so that you know how you are performing, how others are performing, and there is a competitive spirit which is built. So guys, if you are considering joining a crash course, understand it's much better than what you get at YouTube. Good morning, Rakesh. Okay. No anonymous. Okay, come on. Let's do the next question. Okay, let's do the next question. The anonymous, that's for the next one. That's for the next one. Okay, that's for the next one. Now for the astronomical telescope. This is how a telescope looks like. This is the eyepiece. This is the objective. So this is where you see from. This is where you place the, you have that either a star or a distant object which has to be seen from this side. Now, in case of a telescope, the things are very different. In fact, it's quite the opposite. It's quite the opposite. Look at that. Yep. First thing, you will see the eye lens. This eye lens is more powerful than this lens. Yes, this is more powerful than this lens. So the focal length of the eye lens is smaller. That means it has more power than the objective. Next thing, the diameter of this is smaller than this one. That's the next thing that you should know. Obviously, telescopes on the other side are larger. The one near the eyepiece is smaller. Okay, and the last thing, the resolving power. The resolving power, again a similar thing. Resolving power tells you how powerful is the telescope in splitting two bodies which are close by. If two bodies are close by and you can still see them, that means it has good power. If two bodies are very far, still you cannot see them through the telescope, then it has a bad resolving power. So it's the smallest, but instead of distance, it's angular separation. Angular separation means the angle at which the two bodies separate each other. Okay, not the physical distance, the angular separation between the two bodies. It's the reciprocal of that, and the formula is 1.1 1.22 lambdas inverse. That's the formula for the resolving power. Keep this in mind. Okay, so very, very important formula. 1.22 lambdas inverse is the resolving power. Lambda is the wavelength of the light used, nothing else is needed. Let's get going to the ray diagram quickly. Let's get going. Now, the first thing, usually, obviously, telescope is used to see distant objects. That means the object will be at infinity. The rays from infinity will merge at the focus. You can see that. Very far objects, rays will come from infinity, merge at the focus. Intermediate image is formed at the focus. Now, approximately at the focal point, you place this image such that when it becomes the object for the next lens, this is the image formed from infinity at the focal point of the objective lens. This image is going to become the object for the eyepiece. If you place it roughly at the focal length, then you will see the image will be formed at infinity but at a much larger angle. Now, because it is at a much larger angle, you will see it magnified. So when you look at Jupiter or the moon, okay, you will see it far away, but you will see it as if it is stretched from all the sides, that is, it is zoomed on every side. So that is what the ray diagram looks like. And very important, the length of the tube, there is only one formula, so you should feel happy about it. The length of the tube, you can see it is FO plus FE, as simple as that. And the magnification formula is F0 by FE, as simple as that. Magnification formula is F0 by FE. Yes, Jyoti, the PDF will be provided. Yeah. So Parth, what you should do is keep a notebook on the side and keep writing down the formulas few number of times, draw the ray diagrams very quickly side by side as I am teaching, okay, and use that notebook also to solve the problems, and whatever I am doing, just write it. Again, do the same things again after the class is over wherever you found it difficult, and try to write down these formulas, solve the problems from your other books as well, so that you get a good grip of this particular topic. Yep, do that. Let's do some questions, you will get a hang of it. Okay. Cool. Yeah. The objective with large apertures are used in telescope. Large apertures means large diameter. So read the word aperture as diameter. A big diameter is used for the objective. Why is it used for telescope? Why do you think? Why? What is the reason for that? Greater magnification, greater resolution, reducing lens aberrations, ease of manufacture. Okay. Now obviously when you have a large lens, making it for a very small focal length is very difficult. It will create a lot of errors. So actually the answer is greater resolution. Greater resolution. So guys, see, when you have a small opening, the light rays will diffract. Yes, it will diffract and it will create an unresolved image. But when you have a big aperture, then the diffraction is not there, or it's negligible. So when you have a big objective, the diffraction of light is negligible and you will get a very good resolution. That's the real reason for that. Keep this in mind. Yeah. Now the next question, very easy question. A lot of people leave this question because they do not know the formulas. Trust me, it's just difficult till you actually see the solution. A telescope of so and so focal length and so and so focal length, what is the magnification? Come on guys, this is very simple. Thank you, Anurag. Okay. So, what is the magnifying power of this particular telescope? Do you guys know the formula? The magnifying power of a telescope, I just told you, magnitude wise, is F0 by Fe. The magnifying power is F0 by Fe. Do I know F0 and Fe? I think so. Objective's focal length is 200. Eyepiece's focal length is just 5. 200 by 5. How much it is going to be? 40, right? Is it not going to be 40? Yes, it's option A. That's it. F0 by Fe. Nothing more, nothing less. That's simple. How will you even feel like leaving this question? Won't you feel bad to actually leave this question? If after the examination, imagine some friend of yours comes and tells you, hey, I just solved this question, I got 4 marks. And the formula is nothing but F0 by Fe. You will break your head. You will be like, what the hell, why did I not study telescope? I should have just done that. I would have got 4 marks, and 4 marks is going to change your rank by few hundreds or thousands. Okay, let's go to the next question. The magnifying power of a telescope with a tube length is 60 and the power is 5. What are the focal lengths of the eyepiece and let's say objective? Let's see this. Okay, do I know some formulas? Let's see what and all formulas I know. The length of a telescope, the formula is f0 plus fe. I just told you this. f0 plus fe is the length. Okay, and the magnifying power, well, that's f0 by fe. That's the formula. Okay, now let's see what and all do I know. I think I know the length. Length is 60 and 60 is f0 plus fe, and magnifying power, well, that's 5. So 5 is f0 by fe. Oh, that means f0 is 5 times of fe. f0 is 5 times of fe. I can just use this over here. So instead of f0, what I can do? Instead of f0, think about it. Yes, so let me just put f0. So instead of f0, what I'm going to do is put 5 times of fe, and that fe will come here as it is. So this will become 6 fe, correct? Okay, so this is 60. So therefore, fe is going to be 10 centimeters. So that's the answer, 10 centimeters. Where is it? It's option D. So guys, the last leg of preparation has started. The board examination has been cancelled, but JEE examination will not be cancelled. I am telling you this. I mean, it's not yet announced, but don't worry, it will not be cancelled. You might have 1 attempt or 2 attempts. Now that's a decision which has to be made, but the JEE examination date is very close by is all I can say, and maybe the announcement date is even more closer. So the moment it is announced, I think the dates will be very quick. I think you have roughly a month's time, and in this month's time, I feel you should enroll yourself into the course that I am going to talk to you about. And this course will take care of the 11th and 12th both syllabus for JEE Mains. It will also help you for BITSAT. It will also help you for the MIT exam. It will also help you for the next round of VIT EEE exam. So all these courses are taught by experienced teachers with experience of 6 years, 8 years, 11 years, 12 years, these kind of teachers, and you're going to have test series and you are going to get doubt solving. In fact, I can show that to you out here. If you just watch our video, in fact, in our description box out here, okay, and if you go below, you will see the link to join the crash course. That's the link. Now you can see the dates are given. You can choose 31st May. You can get the recordings of whatever classes you have missed. I would say either choose this or choose this. Okay, either choose this or choose this. There are 90 sessions. Okay, very important. There are 90 sessions along with strategy sessions, full length test series and part syllabus test series with detailed discussions, and solution key will be provided. You will also get the PDF, and you will also get doubt solving of all doubts from morning till night. Now guys, if you look at the course price, it's not much, it's 10,000, but you get more, 40% off by using the coupon code SHCC. So when you say buy now, you will see you have saved 4,000 rupees using this coupon, and you can pay using any of these options. And I'll tell you the best part, if you choose an EMI option like this, you can pay just 2,000 rupees per month for the next 3 months. That's even better if you feel you have some financial constraints out there. So when you say proceed to pay, that's it. You can go ahead, make the payment, make sure you have used the coupon code so that you get maximum discount out there. Okay, bye bye, take care guys, and next class will be tonight, and I'm coming up with a special series for 2021 students. The Zero to Hero series is over. Guys, what do you want me to do next? Please let me know in the comment section below, because I want to listen to you. So whatever you think should be done next, I want to come up with a new series. You can suggest me a new name also, that's okay. So the Zero to Hero series has around 22 to 23 classes. So guys, be ready. We are going to get you prepared on YouTube combined with the crash course. Remember, when you use the crash course and YouTube together, nobody can stop you from getting a good percentile and a good rank. Use both these tools together. Just don't use YouTube, just don't use Crash Course, use both of them together. Trust me, your performance will improve like nothing. Okay, so guys, think about it. Whatever you want me to do, please let me know in the comment section below. Join the Telegram group. Do not forget to hit the like button and the subscribe button in case you haven't done that. That's it from my side. Shreyas here. Hasta la vista. Take care. See you.